All right. Well, good afternoon, everyone, and welcome to today's webinar on investigating fall fatalities, lessons learned, and tools for prevention. To those who joined us for yesterday's FACE program webinar, welcome back. I'm Scott Breloff, Acting Coordinator in NIOSH's Office of Construction Safety and Health. I'll be moderating today's session and the question and answer following our panel presentations. We did get a few questions submitted ahead of time, so we will do our best to get through those and as many live questions as possible in the 45 minutes allotted. The National Campaign to Prevent Falls in Construction was launched in 2012 through the NORA Construction Sector Council, with leadership from NIOSH, OSHA, and CPWR. Each year, as part of the campaign, safety stand-downs are held by employers across the country to focus on fall prevention. In support of the campaign and stand-down, our three organizations have conducted a number of webinars in the past, as well as created a variety of fall-related videos, which are gathered in a playlist on CPWR's YouTube channel. Falls are the leading cause of death among construction workers, accounting for about 1 in 3 construction fatalities. Among the most affected are Hispanics and roofers. We can learn a lot about preventing falls by understanding more about the circumstances surrounding these tragic events. Today, you will hear the results of 2 Fatality Assessment and Control, or FACE, program fatality investigations, one involving a Hispanic roofer in North Carolina, and the other a gutter installer in Kentucky. Finally, we will close with a discussion about a NIOSH tool that can be used to prevent falls, a daily inspection tool for a mast climbing work platform. That's why we invited Jennifer Lincoln, Michael Turner, and Brian Weimer. Jennifer Lincoln is a member of NIOSH's FACE program. She is in the Surveillance and Field Investigation branch housed within the Division of Safety Research. Michael Turner is the project manager for the Kentucky Occupational Safety and Health Surveillance Program in the Kentucky Injury Prevention and Research Center. Michael oversees the Kentucky FACE program. Brian Weimer is a lieutenant in the United States Public Health Service. He works at NIOSH in the Division of Safety Research. And with that, I'm going to hand it over to Jennifer.
Thank you, Scott. Good afternoon. My name is Jennifer Lincoln, and I am a fatality investigator at the National Institute for Occupational Safety and Health. Today, I will be presenting on an investigation I conducted involving a Hispanic roofer who fell from a roof. The link to this investigation is actually on this slide here. NIOSH FACE investigators use a methodology derived from William Haddon. We use a public health perspective where injury elements are multifaceted and preventable. We collect data about circumstances and contributors to the fatal injuries through field investigations. This descriptive data is not generally available from injury surveillance databases. NIOSH fatality investigation data support effective prevention measures at the workplace level. The incident occurred at a private residence in a suburb. The building was a 1.5-story building with a complex roof gable. The roof heights varied from 13 feet to 27 feet, and the roof pitches which were between 8/12 and 10/12. The laborer was working on the garage roof that measured 23 feet to the peak and 13 feet to the eave. The residence was located on a mainly flat plot with a manicured lawn with shrubbery surrounding the perimeter. A concrete driveway led to a 2-car garage, and a concrete pathway led to the front door. The 37-year-old Hispanic construction laborer began working his first day on a residential roofing replacement project. He and 7 other employees were assigned by a subcontractor to a 2-day project to remove, replace, and dispose of roofing shingles. He was working alone on a garage roof at the time of the incident. It is believed that the laborer lost his footing and then slipped down the roof, falling more than 13 feet to the concrete driveway. He was not in the view of the other workers on the roof at the time of the incident. Based on photos retrieved from the scene, the anchor for the laborer's fall arrest system was installed laterally across the roof and then pulled from the peak, as you can see in this photo. The lifeline was found coiled near the laborer's hand. The rope grab was attached to the right leg webbing of his harness, and the energy-absorbing lanyard was attached to the roof anchor. Additionally, there was damaged fibers at the 20-foot mark of the 50-foot lifeline, which you can see in this picture. When we evaluate an incident, we gather a list of contributing factors, where if these were removed from the case, the event might not have happened. We found the following contributing factors involving the distance, the roof pitch, the working length of the fall arrest system, the lanyard attachment, the anchorage method, and the worker experience and training. Once we identify contributing factors, we create recommendations based upon these to prevent incidents from happening in the future. We try to place these recommendations in order of precedence. We draft recommendations, but we do not place blame on any party. I think I skipped a slide. I did. I went back. Sorry. There we go. The first recommendation for this investigation was employers should develop, implement, and enforce a comprehensive safety program in the language and literacy level of all employees. The second recommendation was employers should ensure that all employees working from heights are provided with fall prevention training that complies with OSHA in a language and literacy level that all employees can comprehend. In this case, fall protection equipment was provided by the employer, but no training was provided to the employee on fall hazard recognition, procedures for erecting, dismantling, disassembling, and inspecting fall protection systems, or the limitations of the equipment. The laborer was from Honduras, and his first language was Spanish. Employers in residential construction, including subcontractors, are required to provide employees with fall protection systems when employees are walking or working on a surface, horizontal or vertical, with an unprotected edge or side which is 6 feet or more above the lower level. Employers are also required to provide training. A personal fall arrest system is designed to stop a worker's fall before they strike the lower level. In this photo, you can see a personal fall arrest system, which includes, in this photo, a harness, an anchored self-retracting lanyard, and a pull line. Employers should ensure that all employees are provided with properly assembled and maintained fall protection systems when exposed to fall hazards. According to personal fall arrest system manufacturers, the attachment point of the body harness to the lanyard lifeline system shall be located in the center of the wearer's back near the shoulder. You can see the harness there and the attachment point in the back. The laborer had attached the lifeline with rope grab to the right leg webbing of his harness, and the energy-absorbing lanyard was attached to the roof instead of the dorsal G-ring. And you can see in this photo where the lanyard is and where the lifeline is, and that is not attached to the anchor point of the roof. And that was a not well-attached system. And this is the correct order of the system. He coiled the excess slack of the lifeline instead of using the rope grab, which you can see the rope grab in this picture. And he should have used the rope grab to reduce the lanyard slack instead of coiling it in his hand. It was his first day on the job, and he had not been trained to recognize the fall hazards or taught methods of fall protection. Anchorage points used for attachment of personal fall arrest equipment shall be independent of anchorage points and support at least 5,000 pounds per employee, or shall be designed, installed, and used under the supervision of a qualified person. You can see here a correctly installed anchor point. The anchor points for the personal fall arrest system used in this incident were believed to be installed horizontally along the ridge line of the roof versus across it like it is in this photo. Personal fall arrest systems should be rigged such that An employee can neither free fall more than 6 feet or contact the lower level. These diagrams show the working range and the swing fall hazards. There was only one anchor installed on the ridgeline in this incident. The manufacturer recommends anchors to be installed a minimum of 5 feet from the edge of the ridge and at a maximum of 5 feet, every 5 feet along the peak. The laborer's lifeline was rigged at the 25-foot mark with a 6-foot lanyard, which gave him 31 feet of rope, and the fall risk system was anchored approximately 29 feet from the ground. He was also working laterally away from the anchor point, allowing the swing effect in the event of a fall. In order to minimize the swing effect of workers should work directly below the anchor and not extend their work area beyond 30 degrees beyond their anchor point. Employers should assign a competent person to inspect the work site before work begins to identify fall hazards, determine the appropriate fall prevention systems for the workers, and ensure personal fall risk systems are installed properly. And our final recommendation was general contractors should ensure through contract language that all subcontractors have implemented comprehensive safety programs that appropriately address the tasks their workers perform. A multilingual safety program and training may have allowed workers to better understand the safest way to perform this roofing job. You can find more investigations on the NIOSH Space website listed on this slide. You can also sign up for the NIOSH Space listserv and follow NIOSH Space on Twitter. Thank you for your time, and we'll take questions at the end.
Yes, thank you, Jennifer, for a wonderful presentation. And now we will head right on over to Michael Turner.
Hello, everyone. My name is Michael Turner. I'm the project manager for the Kentucky FACE program. Thank you all for that introduction and great presentation there, Jennifer. I wanted to talk about our own fatality that we investigated last year, around July, I believe it was, in which we had a gutter installer who died after falling from a roof. It's kind of a unique case, and you'll see why towards the end of it. So here's some of the incident facts. The incident happened on July 20th of last year. We compiled and produced the report and put it out in November. The victim was a 47-year-old male who was a gutter and siding installer, and the scene took place at a 2-story private residence in which he fell from the roof. Some of the facts on this one: the 47-year-old man died when he fell from a roof while installing the guards on the existing gutters located on the residence's 2nd floor roof. The victim was employed by a small gutter and siding installation company with only 2 employees, the owner and the victim. And the victim had been working for the company for about 4 years. On the day of the incident, the victim arrived at 9 a.m. The residence was about 5,000 square feet, constructed in 1920 on a little piece of land. Most of the house was 2 stories, but each of the wing had 1 story that each measured about 10 feet from the ground. The roof from which he was working was actually another 8 feet 3 inches above the 1st story roof. And you can see from the pictures here, those 2 wings out on each side, those each measured about 10 feet from the lower level. And then the roof of the 2nd story measured another 8 feet. And here's around the side of it. You'll see the driveway here in the lower right-hand corner. That's where the truck of the owner was backed up to when he was at the residence. And that's where he pulled away from right before it happened. So on the date of the incident, the victim was working from the 2nd story roof for about an hour when the owner arrived to check on his progress. The owner had instructed the victim on what part of the house he wanted done first. After kind of surveying what he had done already and informing him on what he wanted done next, he told the victim that he was going to leave in order to get some additional supplies. As the owner was leaving the property, he spoke to the victim's girlfriend, who had actually dropped him off that day for work. She told investigators that she sometimes liked to stay around when he was working by himself just to keep him company. She would stay on the ground and kind of pick up after him and chat with him while he was up there on the roof. So as the owner was leaving the residence around 10:51 a.m., he said he last saw the victim sitting with his legs folded in front of him, leaning towards the gutter. Within about 30 seconds of pulling away from the scene, the owner was flagged down by the girlfriend, stating that she had saw her boyfriend fall from the second story and land on the first floor roof. And by the time that her and the owner ran back to check on him, he had fallen from the first floor roof onto the ground. So in this picture here, this on the second floor, this window here in the foreground, that's right above that is where he was working. And when he fell, he kind of did a forward flip and landed on his back on the first floor roof there. And here are the measurements that were taken. Right about where the top of that 8'3" marker is where he was sitting. Right about the bottom of that one is where he landed. And then when he fell again, he fell from the roof of the first floor down onto where the brick meets the sidewalk. So when they ran back around to the back of the house to check on him, they found him laying unconscious on the driveway. When first responders arrived, the girlfriend had told them, as well as the owners, that the victim had spaced out. He appeared to be working for a little bit and then kind of just froze before he fell onto the first floor roof. She told investigators that she thinks that he began suffering from a seizure, which later ended up being confirmed as a grand mal seizure. And that's kind of the one that's stereotypical, the one that you would think about when you think of a seizure. That's the one where it causes violent muscle contractions and a loss of consciousness. It can be caused by epilepsy, low blood sugar, a stroke, or a fever, or some injury. First responders arrived just within a few minutes, and they went to transport the victim to the local hospital. But in an interview with the EMS responder, they knew that his injuries were pretty severe, so they performed what they called a hot load, meaning instead of taking him to the local hospital, they stabilized him and took him directly to the helipad, where he would be flown to a much larger hospital. The injuries that the victim had: multiple fractures to the spine and ribs, lacerations on his face, as well as a subdural hematoma. He was intubated to assist with breathing when he arrived at the Metropolitan Hospital, but over the next several days, his condition deteriorated until he was declared brain dead. The victim died 7 days later on July 27th. His death certificate stated that he had died due to blunt force trauma and injuries of the head due to a fall from a roof caused by reported seizure issues. And that's where this incident takes a little bit of a unique turn. This is one that we hadn't really looked at before. The medical examiner stated that the victim had been diagnosed with a, quote, unspecified seizure disorder. So when we did our investigation, we found that the worker was working at heights with no fall protection, nor was he trained on any. No hazard analysis was ever performed, and the victim was working at heights with a known medical condition. So we made a couple of recommendations. We informed the owner of the company, as well as when we disseminate this out, that employers should train their employees on and enforce fall protection when working at heights at or above 6 feet. They should also consider implementing a job hazard analysis process for every new job that they're on. And employers who learn of physical disabilities which pose a direct threat to employees' safety should perform threat assessments to evaluate his or her ability to perform the job. So I want to talk about, before we go into some of the recommendations, this employer, 3 years previously, he had been cited by Kentucky OSHA for several violations while performing roofing duty like this. At that time, he was fined for allowing 6 employees working at heights of up to 56 feet. OSHA investigators observed an employee in the aerial lift putting his feet onto the rails and not having them firmly on the basket floor. They were also working from the lift without a lanyard, and the owner never asked for any fall protection certifications for subcontractors. So we know that this employer has had issues, we'll call them, with enforcing fall protection in the past. And just 3 years later, both him and the victim worked at heights at 18 feet without fall protection. And we know that the owner also worked at this height without fall protection because the owner of the residence had a Ring security camera. And so when OSHA gathered all their information, they could see that the owner went back up without fall protection to that top floor roof in order to gather materials. So because he was a repeat offender, Kentucky OSHA, they cited him for the most serious violation that you can have. There were 2 serious willful violations, one of the standard duty to have fall protection in residential construction, as well as training requirements on that. And when they talk about willful violations, that means that they believe that the owner had an intentional, knowing, or voluntary conduct that demonstrated a careless disregard or just a plain indifference to the law. They know that through the previous investigations that this owner knew what he was supposed to do and still ignored it. So do you have fall protection? These are the two that he was cited on here. We mentioned it in the previous one. Anything above 6 feet, make sure you have a guardrail system, lanyard, safety net. And then you also have to provide a training program for your employees if you're going to expose them to working at heights. Job hazard analysis. This was their first day on the job, so we believe that they could have performed an analysis and seen what kind of dangers that they had been doing. And of course, the owner stated that he didn't do one because I'm sure you all have heard it before. They've had plenty of experience in this type of job, and they felt they knew what the dangers were. And he even acknowledged to investigators that he knew working from heights was dangerous. The JHA has been around since about 1994. It's a technique that's used by supervisors and experienced employees in which they focus on job tasks and then try to identify potential hazards that workers may encounter when performing each task. Now the part with the physical disability, this is kind of where it was a unique case. We dug a little bit onto the unspecified seizure disorder that was listed on the death certificate. The victim's girlfriend actually confirmed that he had epilepsy. And so we did a little research on that. Epilepsy is when the central nervous system disorder in the brain activity becomes abnormal and it causes seizures or periods of unusual behavior, sometimes a loss of awareness. And the CDC states about 1 in 100 people in the United States suffer from epilepsy. So the United States Equal Employment Opportunity Commission has very specific requirements when it comes to working with epilepsy, and it's covered under the Americans with Disability Act. An employer may not ask an applicant if they have epilepsy, nor is the employee required to disclose if they have epilepsy. If during the means of work an employer learns that their employee has epilepsy, they may ask for medical information, but they can only ask for information needed to make an assessment on the employee's present ability to perform their job safely. An employer may exclude an individual with epilepsy from the job for safety reasons when an individual poses a direct threat. But the direct threat must be a significant risk of substantial harm to the individual or others that cannot be eliminated. So if the owner had done a direct threat assessment here, he could have also taken into consideration the duration of the risk, the nature of the severity of potential harm, and the likelihood that the potential harm could occur. We believe that if he had done this direct risk assessment, not only would he have realized that this individual was working at heights unprotected with a known medical condition, that he was oftentimes working by himself. So even if he did have fall protection of some sort, say he was wearing a lanyard, if he was by himself and had fallen while experiencing seizure behavior, there's a very high chance for suspension trauma. So I think if the owner had done his due diligence, we believe he might have realized this. The owner was aware that the employee had suffered from seizures in the past, but he did continue to allow this employee to work at heights unprotected. And we recommended that once the employer learns of the disability, the employer should perform that direct risk assessment and evaluate the employee's ability to safely perform their duties. So what happened afterwards? I actually filed an open records request for the case. The owner was fined $145,000, 2 willful serious violations, as well as a less than serious violation for failure to report the hospitalization. The owner he filed a formal contest of the charges, claiming the worker was only a contractor. You know, I'm not a litigation officer. I don't know if that's going to hold up. It seems like the employee had worked solely for this owner for several years now. I mean, just for me, it's a pretty lame excuse, but that's what he was trying to go with. And as of this presentation, the litigation is ongoing. So based on this, we actually made this little infographic for the presentation here, talking about the construction workers that have died from falls between 2000 and 2018. Going back to Jennifer's presentation, we have almost 1 in 5 construction workers who fall who are actually Hispanic. Most of them do fall, well, a plurality of them fall from roofs, and we actually see that almost 1 in 4 take place on a Friday. Here are our sources, and that's the end. So thank you all for letting me present, and I'll turn it back over to Jessica and Brian.
All right, thanks, Michael, for your wonderful presentation. Appreciate it. And then we'll let Brian talk about his safety tool.
Hi, everyone. This is Brian Weimer. I just want to thank you guys for the opportunity to present today on a tool that we developed that came out of a small pilot project. And I want to also thank my other team members who have helped me on this project, Brianna Eider, Christopher Pan, Tim Orr, and Sydney Webb. So to jump right in, for those who might not know, what is a mast climbing work platform, or a mast climber as it's known? So you'll see here a picture of what would be considered to be a typical configuration of a mast climber. So a mast climber is a powered work platform that is hooked onto a mast, and that platform can then be driven up and down the mast to get workers to height to perform their work. So the platforms themselves can be configured to building configurations, as you'll see in this picture. There are different attachments that can be put on mast climbers. They can be freestanding if the work needs that. Typically, they are also fixed to a structure, some kind of an adjacent structure. So these are also becoming more popular in the U.S. as a way of replacing traditional scaffolding, or just kind of an alternative depending on what the different building and structures that are being worked on are. So it's estimated that in the U.S. every day there are up to 15,000 mast climbers being used. Most of the time there will be 3 to 4 workers on each platform section. So that's a close to 50,000 workers that could potentially be on mast climbers every day in the U.S. So one of the other things with mast climbers that makes them attractive to companies is that they are relatively easy to assemble and disassemble and move around at different parts of the construction site. And it's estimated that a typical mast climber on a job site would be taken down and put back up maybe 4 to 5 times a year as they move it around the site or the building. So at NIOSH, we have performed several other research projects with mast climbers. Before we did this, though, we went to the Fracco site in Baltimore, and all of our team members took installer and operator training courses just to familiarize ourselves with the equipment, what everybody else who's taken this training would be trained on before they were going to use and be certified to install or build mast climbers. So once we did that, we had a project that we looked at the stability of a freestanding mast climber with different platform loadings under a fall arrest scenario. So we took our fall arrest mannequin and we took him to the end of the platform to different platform configurations, and then we measured the stability of the overall unit and then also the actual platform movement itself. So one of the other projects that we just finished up recently was looking at the material handling aspect of mast climbers. Traditionally, mast climbers have been used in masonry. That was one of their original design intents. So there are different platform configurations and setups that users will have when doing different masonry objectives. And we looked at some of those different tasks in our motion capture lab to look at the body movement with these different platform setups and configurations. So mast climbers require a daily inspection or a pre-shift inspection. And this inspection is usually just done visually from the ground up. You'll see here a picture of a job site that we visited in September of 2018. This job site was outside of Washington, D.C., had several mast climbers set up by the manufacturer themselves. And then you'll see here it's a little bit small, but this is a daily inspection sheet that will just give you an idea of some of the points as you go down through and look at the mast climber from the ground up, what you would be looking for. So why do you do that pre-shift or the daily inspection? So most of the incidents that have been reported could have most likely been caught if a visual or pre-shift inspection was done and the workers had looked for those things. So the pictures you see here, the left picture, this worker was standing on a platform that was overloaded. The platform gave way and fell, but luckily he was tied off with his harness and lanyard, and he was able to climb back up to the edge of the building until his coworkers could pull him back up on. The picture from the right is a picture from the Raleigh-Durham mast climber incident that many of you will know about or have heard about, where 3 workers lost their lives and 1 was seriously injured. And in that case, looking at the OSHA reports, there were 2 or 3 major things that could have been caught if a visual inspection was done and the equipment was looked at before they were using it. So the daily inspection walkthrough tool that I had created has 7 pictures that we took at the job site with 19 inspection points. So what it is designed to do is just to help users familiarize themselves with potential safety issues or things they would encounter when using a mast climbing work platform. So the users are shown highlighted areas that they would look, and then we'll click on that area, and then it will kind of walk them through what that area is being highlighted for, what the inspection point is, and potentially what the OSHA regulation would be that would dictate why they needed to look at that one specific point. So who would use this tool? The people who would use this tool would be operators, installers, as a refresher, who maybe have not been using the equipment. Maybe the company put it up for a while and then got it back out. Those who have never used the equipment that just want to familiarize themselves with it, or the non-competent persons who are on the equipment, the workers who are on it every day that, again, maybe they had been out of the construction industry for a while and then came back and were going to use it. But we definitely want to stress that this tool does not replace official training in any way, shape, or form. It is just a tool that it can be used as something of a reminder or a refresher for those using the equipment. So what you see here is a picture of what you would look at when you first pull up the daily inspection walkthrough tool. So as you see here, this is a ground-based structure and then a normal base. There are highlighted areas, and the user will click on those areas. Once they do that, at the top, they will be given the inspection point, what they're looking for. So in this case, it would be making sure that the base is horizontal and level, and that the mast is vertical up and back. And another example would be here with the platform, that you want to look at that, click on it, and you would see that you need to check the guardrail, the in-plank sections are in place, secured, and that if there's going to be debris that could fall, that you have protective mesh in place. And then there are the regulations from OSHA that dictate why you would want to specifically do that. So even though this project has ended, we are still making current progress. So we created a NIOSH subtopic page for mast climbers, and the daily inspection walkthrough tool is on there. There's also a really nice infographic that you see here that was created that we have linked to on the page. And when you scan that QR code, it will take you directly to the mast climbing work platform walkthrough tool. So that infographic is being translated into Spanish, and that also got me to thinking that we might have a way that we could get the walkthrough translated to Spanish. And right now, the CDC translation team is actually doing that. And hopefully very soon, we will be able to have the daily inspection walkthrough tool from start to finish in Spanish as well. So there's a link to that, and I'll be happy to take any questions. And I would encourage you, if you do have the time, to click on the link and to do the walkthrough and to share that freely with anybody. Thank you, guys.
All right, thank you to our presenters. We have about 10 minutes for questions, and as I mentioned on top, we had some that were sent in previously. So presenters, go ahead and listen up and feel free if you would like to add anything to these questions. So the first one says, what can leaders do to mitigate injuries in the minority workers groups? I don't know if Jennifer, you want to take the first stab at this, that's kind of your area.
Yeah, it is. What we have found is that it's training and understanding and hands-on training for them. Everyone assumes that they understand what's happening, and if you can make sure that you can visually confirm that they understand how to use the fall protection systems that they're given, that's a massive way to mitigate those challenges. Is providing the appropriate training and providing the hands-on training so that it's not just communication verbal communication. Anybody else have any additional thoughts?
Jennifer, I think you nailed it on the head during your presentation when you mentioned language and literacy when we're providing training to people. Not only do they need to be in a language that people understand, but also take into account the literacy rate and what lingo you might be using, what industry jargon you might be using. Let's break all this down to people who might not understand everything that's being said, who are new to the industry, and let's make sure that they understand how to keep themselves safe.
Excellent. The next question is a little bit bigger picture, but it asks, in your research, have you seen fall injury trends by state or by size of the company? So they're asking by region, or bigger companies more at risk, smaller companies more at risk?
I'll take a first swing at this. We don't see that all, they don't focus on large companies or small companies. There's quite a few small companies out there. There's a lot of subcontractors. So larger companies tend to have more comprehensive safety training programs and have to follow and are following the OSHA regulations much more strictly. So you might not see as many issues, but they also end up having larger jobs with more employees on staff. So there's no rhyme or reason. It doesn't fit one size of industry, construction industry worker. So everyone needs to be implementing the training and using the fall protection systems correctly all the time, and then we'll make some changes. Anybody else have any thoughts?
All right, thank you. The next question is a little long, but it says, when fall protection is worn, but still results in a fall that may produce a fatality or serious accident, what are the most common reasons for fall protection fails to protect? Is it use? Is it position? Is it failure to select the proper gear? I know both both Jennifer and Michael, you kind of both touched on this. Do you want to reiterate some of your findings to drive that point home?
Well, in our presentation, the victim wasn't wearing any fall protection. In Jennifer's, I believe it was worn, but it was attached incorrectly. When something like that happens, you have to take into account not only is the equipment strong enough for the employee that's wearing it, but also what's the swing radius. If somebody falls off of a roof or a big building, how far out are they going to swing? And also how often or how long are they going to hang there before they are rescued? In our investigation, the employee was unconscious when the fall happened. So if he had been wearing fall protection, I think I mentioned a serious risk of maybe some suspension trauma that could be going on. So if it's correctly worn and it's correctly attached and it matches the weight, or it is rated for the weight of the employee, it should hold up. But I mean, as far as some freak accident in which it does fail, I don't have a lot of experience on that. I would have to punt that one to Jennifer.
And actually, Brian might be able to answer that. Failures a little better than I be able to answer the failures, but it frequently is they're not using it as it should be. They've been trained to use it. It's like in our case, he didn't install any component of it correctly. And even if he had the distance wasn't rigged right. So those are some of the challenges. And also you get into environments like early mornings when there's dew on roofs and that kind of contributing factors that go into incidents. So you have to make sure that your systems are there even if the conditions aren't wonderful. Brian, do you have any thoughts?
Yeah, so from what I know, the engineering companies that do the harness and lanyards and the fall arrest equipment, they usually build a relatively large factor of safety into that equipment. And of the fall arrest testing that we have done, we've not really seen any failures straight out of the equipment. So I would say that most of the time, as you spoke to, it would be misused, not using the fall arrest equipment at all, or misusing it in some way, shape, or form.
Excellent. The next question is, we struggle with protecting workers at heights that are well over 6 feet, but well under this fall clearance needed to use a standard 6 feet lanyard. Can you share some best practices and equipment choices for those working on a 1-story roof?
I would have to pass on answering that fully, but I do know if a 6-foot lanyard is too long, looking at everything from an outside view looking in, there should be some type of fall arrest, something on the market that they could use, whether they would need to contact an engineering company to help them out, whether it would be a solution that is currently there, or they could develop something. But I would think that there would be something on the market that they could find.
This is Jennifer. I know that we have some researchers at NIOSH who developed a system that you can mount directly onto the roof itself that creates a guardrail system. So there are systems out there that you could install.
Perfect. And that actually leads into another question that we got in the live chat that says, would you be able to elaborate on guardrail systems as one of the conventional fall prevention systems? So that's a perfect segue.
I honestly am not the best person to speak on that topic. I know Tom Bobick is our guardrail expert, so I don't know if, Brian, you have any insight from that arena.
I would actually say exactly what you said, that Tom Bobick would be the best contact to make with that as they develop that guardrail system. So I would say, to iterate, that contacting him or looking for his information on the product would be a good selection.
Okay, and then we're really short on time, so the last question is basically going to be directed to Brian. It says, just wondering if the mast climbing system as fall prevention can be applicable to the roofing industry, residential and or commercial as well.
So the tool that we developed was geared directly towards mast climbers. And if you see a mast climber set up in person, you quickly realize that it is kind of an entirely different beast compared to normal scaffolding, where a lot of other hazards out there. A lot of the fall prevention items that are used with mast climbers are your typical harness and lanyards or guardrails. So a lot of the information is relevant, but what we've developed in mast climbers themselves, all of the fall arrest and safety systems are really strictly for mast climbers.
Excellent, thank you. So again, we are out of time. I'd like to thank Jennifer, Michael, and Brian for your wonderful presentations, and for all of you attending our webinar today, and to have a wonderful weekend. And that is it, unless Jessica has anything else to add.
No, thank you all for your presentations, and thanks, Scott, for moderating. I will add one thing. I just put the YouTube playlist link in the chat. We have done a number of webinars between CPWR and NIOSH and working with external partners and stakeholders that cover more technical topics, such as what you use in different roofing situations, et cetera. So please check that out, and I will share it in the follow-up email as well. Thank you all for joining.